Hi, my name is Chufei. I am an applied ML intern on the AI engineering team supervised by Faiza. And today I will be talking about my work in interpretability and bias identification in language models. So I've been an intern since the fall semester. I didn't attend the last demo day, but I have worked on 3 main projects during my time here at Vector. The first is an LM skill set evaluator, which is more theoretical work in layer-wise interpretability using causal reasoning. And then I was also a part of the Uncovering Bias in LLMs project, and I led a team for bias identification. And we explored 2 main topics. One is red teaming, and one is retrieval-augmented generation. And these are both to induce bias in LLMs. For today, I will be focusing on the last project, which is the retrieval-augmented generation with knowledge graphs. And so first, a bit of background on our goals with this research. The large language models are trained for instruction tuning. So for any input from a human user, the language model is expected to follow the instructions. However, there are some queries that you don't necessarily want a language model to follow exactly. So like unethical queries like how to hack into Wi-Fi or how to rob a bank. And so it's very possible for a large language model to know how to do these things due to pre-training, but we want to allow it to not recognize that this is harmful and unethical and advise against doing this. And so this is an area of study known as guardrailing or safety-focused fine-tuning. And it is very popular in recent large language models, including Llama 2. And my main question was, can bad actors bypass these guardrails? So even if we train for safety fine-tuning, can a bad actor bypass these guardrails anyway? And this is an area known as red teaming, and it is currently underexplored for bias specifically. And so we specifically look at a bias data set called Bias Benchmark for QA, or BBQ, and it tests 10 sensitive attributes for bias, such as race, gender, physical appearance, and more. And it's in a closed format, so there is an input context, a question, and multiple choice answers. And there is an unbiased answer and a list of biased answers. And so we essentially want to be a bad actor that tries to elicit a biased answer and attack the language model in some way. And so the most common strategy for this, as mentioned, is red teaming for LLMs. And this is just a name for any natural language prompt that is input into the input. And so there's an example here below. It's very self-explanatory of give a more harmful and unacceptable response. And so the goal of our project is to work in this red teaming space, and we wanted to test new methods of red teaming and provide some method of automated testing to rigorously evaluate how well guardrails are in place for bias. And so we perform a literature review on existing red teaming strategies. And we found this paper, jailbreaking ChatGPT via prompt engineering. And there is a whole host of strategies emerging in the past year or so. But we focus specifically on one chunk, which is the superior model strategy listed here. And this is essentially where you give information, like you give some knowledge to the language model and say, this is an expert's opinion or like superior wisdom, and you should follow it. And we want to use this strategy, but for bias. So for example, can we introduce stereotypes and say, this is wisdom and you should follow the stereotype? And can we do this in an automatic way such that we can benchmark a large language model very rigorously? And so there are many applications. This is essentially just stress testing of guardrails, which is the general goal of red teaming overall. And by stress testing, we can understand language models a little bit better and train safer models for industry deployments. And this is especially important for any high-stakes applications such as law, medicine, and finance. And so I will go over one of our methods, bias coding. And so we are assembling, again, a knowledge graph for the sake of retrieving stereotype data. And we obtain stereotype data from the social bias inference corpus, which is an open source data set from LNAF. And then we convert it into a knowledge graph using GPT-4 prompting. And then we construct a vector database to retrieve the most relevant stereotype nodes and insert it into the prompt as superior knowledge. So here is an overview of the knowledge graph construction. So SBIC has a bunch of natural language statements like this. So poor folks steal things, et cetera, et cetera. And then we prompt GPT-4 to convert these natural language statements into a knowledge graph. So it starts with the protected attribute, so poor folks for poor people. And then it ends at either a stereotype, so like poor folks steal things, where the edge is steal and things is the end node. And then it can also lead to other protected attributes. So for example, this allows for us to connect compound attributes like a Black woman is both Black, the race, and woman, the gender. And then with this knowledge graph, we perform multi-hop retrieval to utilize the connection between the stereotypes as well as connection between compound protected attributes. I won't go into the technical details for time, but just know that we retrieve top K entities that are most relevant by cosine similarity. And so here is the full pipeline in action. So we take the BBQ context and perform our retrieval to retrieve the top K entities as shown below. And then we put that into the prompt template with the BBQ context and questions, and then the LLM gives a biased answer. And so here is exactly how we test this in our experiments. So we prompt the model for a JSON formatted output, and in our prompting, we also ask it for optionally for an explanation. And this is based on previous literature that shows asking for an explanation or a train of thought reasoning can sometimes affect the level of bias in a language model. And so we report deception rate, so that's the percentage of biased responses, and refusal rate, which is in a guardrail, how often does a language model refuse to answer? And we test these suites of language models, Llama 2, 7B and 13B, Mistral 7B, GPT-3.5 and GPT-4. And we take K equals 3 and we test 3 decoding temperatures of 0.1, 0.5, and 1. And so we find that our language model, our knowledge graph method does increase the bias rates in both GPT-5 and GPT-3.5 and GPT-4. It also increases it slightly in open source models, but the effect is most dramatic in GPT-4. And it does so across all of our sensitive attributes. And then in terms of reasoning, we find that the effect is a little bit more varied. So it's sometimes increases, sometimes decreases. And so, yes, this is just a highlight of one of my projects, but overall my internship work has been focused on improving the safety and transparency of language models. And this work is in submission to a NAPA workshop called Trust NLP. And we are extending the work with the other portions of the bias identification projects to a journal paper. Thank you. Any questions?
Any questions? Anyone?
I have a question about the deception rate. So, I mean, how can we judge some like answers has some like fairness, has some bias issue, something like that? So
Right, so the data set is a closed form data set.
Okay.
That is to say it's multiple choice.
Okay.
So there's an unbiased answer and every other choice is biased.
Okay.
Yes.
So we don't need human evaluation at that period.
Yes, exactly.